Hey everyone, how's everyone doing out there? This is the beginning of more non-conventional national security issues, and one is the idea of climate change. If the world gets hotter, what are the national security ramifications? So you see something on Bangladesh, you see how this is a national security issue, not just for the United States, but particularly for smaller, poorer countries. But the question is, anyone can say it, right? Hey, this is a national security threat. Hey, climate change is happening. Glaciers are melting. How do you test it? See, this is where the real research comes in. How do you test it? And that's what we're going to do with our sea ice data set. We import it, like pops up. We're going to take a look. Boom. So we have, again, as I've been saying, large N, 37 pieces of data. We have the year 1979 to 2015. Now, I know for a young kid, they say 2015. I wasn't even born, some of those students out there. But we're going to use extent. That's sea ice. The sea ice that I think it makes up 15% of the area or something like that. I'm not going to pretend I'm a climatologist, but each one, extent, as you can see, is more than area because the extent of sea ice doesn't have to be like the whole entire area, but we're going to do both. Area means that the whole area is covered with sea ice, according to this. In fact, I'll even read it. Although area and extent may sound synonymous, they are different measurements rendering different numbers, even from the same satellite observation. What they basically say is extent is the total region with at least 15% sea ice cover. So you get a lot of water there. Whereas area is the whole entire area. So it's thicker, as you can see. So extent is intrinsically going to be bigger in this case because, you can have just 15%. So there's going to be a lot more extent. But regardless, extent to area, these are measurements of sea ice. So the question is, everyone talks about climate change, sea ice, etc. The poor polar bears, or is it the penguins? I forget. I think one lives one place, the other lives another place. So what's happening here? That's what we're going to see with our regression analysis. This is what real research does. So are we getting hotter? So let's call this something. Oh, we didn't attach it. You have to attach a data set every time, just about. So R can recognize it. So now you say to yourself, okay, let's call it Heat Miser. Probably no one remembers that. That was a show from a long time ago for Christmas, the Heat Miser. So LM function. Now the year itself is not the independent variable, right? Although we're going to use it as an independent variable to see if throughout the years, the extent and area of ice have decreased or increased. So you have a null hypothesis, right? The null hypothesis is there's no relationship whatsoever. It's just all over the place. The alternative hypothesis is the extent has increased. And then the second alternative hypothesis, has decreased. So let's take a look at extent, right? You get that extent. Then we're regressing it, Tia tilde up there, with year. Oops. Look at all the years there. Don't get confused. Oh, I better know I'm doing the right year. That's when you really have to put in data equals sea ice. Boom, boom. Now we do a summary. Oh, no, wrong one. Heat miser. And we're going to see the extent to which this is significant. Okay. No binding for sex. What's going on there? All right. So it's basically saying for every year, sea ice is decreasing. Let's take a look at this data set. Yep, decreasing. I just want to take a look there by 0.08. You have a very small standard of error, which is good. And then you have a t-value, which is high, which means it's moving from 0. And you have a very low p-value, which measures, or supposed to measure our confidence level. Let's do the format here. Put in this in the non-scientific. And see the exact number. So we've got, wow. I mean, that is saying it's very, look at that. Multiple R squared, 0.74. That's very high. And that's a very low residual standard. So let's take a look at this through ggplot. So, and then we can kind of get a good idea of what's going on. It's called sea ice. We're going to plus the aesthetics. The X is year. Oh, man. There's too many years in my thing. And then let's take away using extent. And remember, this is geom point. We're going to do other geoms. Let's just say color equals. What do you like? I like the purple. And then plus stat smooth. I want to show you what it looks like when I don't put the false in there. Or the method LM. So yeah, I'll just take out stat smooth to show you. All right. So there's no line, right? Because there's no stat smooth. But it is going down. That's why I like stat smooth. So I'm going to put down stat smooth. But if you don't put the method, we're going to show you different things here. You've got a different type of line that kind of goes with it, the flow. Now, that's not necessarily a bad line because it's showing you where it's going. It goes down, then it really starts dipping by 2000 and starts dipping away. This gray color is kind of pushing out towards the line. So this line is called the best fitting line from the OLS model, not robust base. And it goes, ooh, boom, right? So if you want to just make it a straight line, you would put method and then get rid of that. You would say equals, I do not know why, why it says say, I know in Spanish, I don't know. But so this is it. This is pretty straight line. I mean, if you look at it, that's a pretty amazing, the last one, 15 here, line going down. So we just tested climate change. Now you have to, I will apologize to your alt-right uncle or whoever is against climate change. Who is that individual that was always saying climate change is fake in the last presidential primary? I'm sorry, it does seem, according to this data, to be going down. But this is how we test it. Let's even just get rid of the extent and run area. So the area is going down as well. So it seems like, I apologize to all the naysayers, and I know they'll attack me for being your quintessential liberal professor, but from a national security perspective, we need to do something. Even Newt Gingrich himself, if you watch Climate Refugees, concedes we have to do something about this. I'll put it on supplemental. That is that documentary, Climate Refugees. So this is a national security issue if the world is getting hotter, which leads to the decrease over time, as we're seeing, to the area and extent of sea ice. We need to address this. And this is extremely significant. I mean, look at it. For every year, 0.09, just say, sea ice is decreasing. A very high t-value, that's where these are moving down, right? They're moving with the line. They're moving away from 0. The p-value is telling us this is attributable to the independent variable year and not by chance. It's moving down, as you can see. This multiple R squared is saying, this is very correlated with each year going down. And residual standard error, which is low, is showing us the values and how they kind of deviate from this line, the extent. These are sum of squares. You can actually put lines here to show you how much they're deviating, but a point 0.7417 is a very good correlation in the social sciences when you start looking at it. So thanks for listening. And I guess climate change, I apologize to all the naysayers, but it does seem to be happening. Take care, everyone.